Now for the next question in the paper, in 2022 it was assembly language, and it's the same in 2023. That's also up in the controlled assessment, in the Google Classroom window. There's 2023. Now in 2023 it gave a sample of assembly language code for you to enter in, and then to output the values whenever out appeared, and there's 4 times that appears, then for that to be output and you write it into the exam workbook. So it looked a little bit differently in 2023 to how it has before. I'll just show you 2023 electronic answer book, and let's go to question. Let's go through, and here we are, the outputs you had to type into here from the program in the exam question. Now that wasn't the case in 2022, so let's see what was required then. Now we're going to use, just for this purpose, the peterhigginson.co.uk/LMC little man computer in order to work out what happens with these different commands in assembly language. Now recall also, if I go into Google Classroom, I'm just going to go back a little bit here, and I'm going to find in here, it's in the textbook, and if we go to the GCSE textbook, let me just, on page 138 are all the commands you need to know: the input, the output, store, load, add, subtract, branch, or the loop. Haven't seen a question that's required that as yet, but it may very well do, and that'll go to a particular line. Halt to finish, make sure you put that in. I often forget that myself. And also DAT, the data. So we'll use those commands now in the LMC in order to perform 2022's question. Well, first of all, it says state the assembly language to output a value. So that's OUT, load a value, LDA, store a value, STA, and add 2 values together, that's add, ADD. So you can see that straight from the textbook. Write an assembly language program to load 2 values and add them together. So let's go and see how this works and just remind ourselves how the LMC works. There is another video in our classroom that allows you to do that. INP will input the value. STA will store into a number. Now I'll use number 51 just because it's very close by. Okay, and then we'll have input another value. We'll store that into 52. Now there's a quick way of doing this. We've now got a value in the accumulator, so if I run that, in fact submit that, there's the program, but I'm going to store values into 51 and 52. So if I run the program, I've got it set to be medium from previous, so I'm going to do fast. There's the instruction, input from channel 01, that's the input, so I'm going to put in the number 17, right, so that will go to the accumulator. The next command is got, which says STA, that's instruction 3, 51 is the address, so that's going to say 351, store into address 51, and it takes from the accumulator. There we are. Now it goes and gets the next command, which again is an input command. So I'll get ready to input another number, which is now going to be, so I'll put 12. There we are. Now the next command is 352, which means store into memory location 52. So it's going to put it there, and then we'll see what happens then after that. So let's just enter that value 12. Off it goes to get the next instruction, and you'll see then, when I get after this, I'll make sure we put it fast. So 352 goes and takes the accumulator off to memory location 52. Alright, now the last command should be halt, HLT, but there isn't one, so it's now going to finish in any case. So really speaking, I should, at the end of this, let's put HLT and click submit, and it'll put that there. This is the program you're supposed to write, not this one. So now let's go and extend this so that we start loading some of this data. LDA 51, add 52, and then we're going to output that value. So what that means is it's going to load the contents of 51 into the accumulator. Then it's going to say add the contents of 52. So that's, you'll see two numbers appear here. They go off to the arithmetic logic unit. 17 and 12 get added together, written to the accumulator. The number 29, the total. And then it says out, which is out to the channel. It's input output. It'll say 902. There we are. Output. And then we got halt, which is the command 0. So if I run that, we're now going to run that. So it'll happen a lot quicker than previous. So let's just see. Submit that and let's run. So let's put the number 12 in. Off it goes to memory address 51. It's got 12 in the accumulator, but it's waiting now for me to enter another value. So I'll put 18 in. Alright, now that will get stored into 52. Then the next instruction gets, which says load 51 back into the accumulator, so it'll put a 12 back in there, and then it will 52 add location 52, and then let me put that as normal. Let's go and run that now. Let's go and see what happens with 18. So it goes and gets the instruction 352, which means store in location 52. So it takes the accumulator off to 52. And then it goes on the address bus and the data bus, goes and gets the next instruction 551, which means load memory location 51. So where is it? There it is. It's the number 12, so it's now going to replace in the accumulator, and it gets the next instruction which says 152. Now instruction 152 says go and get from memory location 52, go and get the number 18 that comes along the data bus, take this off to the arithmetic logic unit, put 30 back in there, and then it'll go and get the output and then halt. Let's just finish off here, and we should see the output comes up here, and there we are, there's the number 30. So that's how to add two numbers together. Now in 2023, let me just go to 2023 and let's see what, in fact it's the exam paper 2023 I want to have a look at. So if I just minimize that, that's in the classroom. So if I go to past paper exam 23, let's go to the particular question, and it says write a language program which accepts 3 numerical inputs and adds them together. So you just have to see that by adding two numbers together, this is what we do. Well, in fact, before I output, I don't want to. I want to. If I add number 52, location 52, I can then store that in location 53, so that's like a run-in total. Then I input another value. Let's then add location 53 to that value and then output that. So if I click submit, I've got it on fast, that's fine. So let's run. So it's after a number 12, that's going to get to 51. So there's 12. Let's go and add 16 to that. So it's now put 16, but it's put the running total now stored into location 53. Now it's asking me for a third value, so this input statement here, and it's going to say add location 53. So let's just put 2 in. So that'll go to the accumulator. It'll then go and get the value 28. It'll add to it, and again it's going to output the number 30. So that's adding 3 numbers together, so keeping a consecutive run. Now that's not the only way of writing that program, but that's certainly one way of doing that. Okay. Now, what the examiner has used though in the past is the examiner has accepted last year, accepts the numbers, the memory locations themselves. However, you can, after the halt, you can stipulate some data locations. So I'm going to put in location first. Then I'm going to do data location second. I may want a data location called total. We don't know. We could put that in there. And instead of using 51, we'll put first. Now what this allows is for the computer itself to determine where this gets stored. So rather than me identifying that it gets stored in location 51, what it'll actually do when I do this, let's just submit. Just to note, the Peter Higginson model has to have the name of the location firstly and then dat, but in your exam put the name afterwards. So but we're just indicating that it's we'll store that there. LDA, then I'm going to load the first number again, then I'm going to add the second number again. Now I don't know where these are stored, but this will control that. Store into total, and then input another value, add the total to it, and then we output that value. Let's click submit, and it's stored that. Now what you'll see is the program is written here. In fact, I've taken halt out. Let me put HLT. Let me put halt back in. So halt is back in. We've assembled it into RAM, and I'm going to run that. Now I'm going to, first of all, let's put the number 16 in. Now 16 is going to get stored in location 11. Halt is here. Here's all the other code of the program in sequential locations, and there is the data which is labeled first, or first number, or first area. I've called it first, and that's where it's going to be stored. Then the next number is going to be, let's put the number 19 in. Let's just do normal, and let's go and see what happens. It goes and gets the instruction. The instruction is going to be stored into location 12. Now I haven't even mentioned 12 here, but the computer has determined that location 12 will be called second. And there we are, it goes off there. Now it's going to get LDA first, so it's 511 from load address location 11. So off it goes to 11, gets the number 16, puts it into the accumulator, and that's the way you build it up. And I'd say it's quite easy to work with. You know, it's certainly different to Python programming, certainly different to Visual Basic programming that we've done before, and it's certainly very much different to HTML programming, but certainly easy to follow through. So I'll stop that. Well, in fact, I'll keep it running, and off it goes and gets the total now in a bit.